Our last lesson of the school year. Here we go. Rotations. A rotation can be thought of as a turn the same size in the same shape. So in other words, if I were to talk about a rotation, let's say I use my calculator here. If I wanted to rotate this clockwise, I would be rotating it this way because that's the direction the arms on a clock work, right? If I were to rotate counterclockwise, I would be rotating this way. Notice my calculator is not changing any shape at all. It's not changing size. It's not morphing into something. It's simply turning around in a circle. So if I were to rotate 90 degrees, I'm going to stick with clockwise for right now. Clockwise would be a quarter turn. Should be perfectly horizontal. If I were to rotate another 90 degrees, meaning I've rotated how many degrees total? 180 degrees, it flips it around upside down. If I rotated another 180 degrees, meaning 360 degrees total, I've rotated it all the way back to where it starts. Now, if I rotate counterclockwise, 90 degrees looks like that. 180 degrees counterclockwise looks like that. Over here would be, this is 270 degrees counterclockwise, and then 360 degrees always brings you back to start. So that's what we're looking at when we're looking at rotation. So how do we deal with rotations? So we have some rules, okay? There is a picture here. It shows you some rotations, 120 degrees, 240. We are going to focus specifically on 90-degree rotations counterclockwise, 180-degree rotation. Now 180 degrees, it doesn't matter which way you're going, whether you're going clockwise or counterclockwise, because either way you're going to end up upside down. 180-degree rotation is the same. 270 degrees counterclockwise, and 360 degrees. Now 360 degrees, notice XY stays as XY. It's just a perfect rotation all the way around in a circle. When we have a 90-degree rotation counterclockwise, so let me think about this. Let me go back to my calculator. 90 degrees counterclockwise means taking my calculator, try and get it straight here, taking my calculator, 90 degrees counterclockwise means the display is over here on the left. Okay? That is the same as if I rotated it clockwise. Looks like 3/4 of a turn, which is 270 degrees. So 90 degrees rotation counterclockwise is the same as 270 degrees clockwise, because both end up with my calculator at the same way. And that means you're going to take your X and your Y value, you're going to switch them, and you're going to take the opposite of your Y value. Negative Y means you're going to take the opposite of it. So if it's positive, you make it negative. If it's negative, you make it positive. Okay? A 180-degree rotation, X and Y stay in the same order. You just flip the signs. You take the opposite, negative X and negative Y. 270 degrees counterclockwise. So again, if this is my rotation, 270 degrees counterclockwise happens to be the same as 90 degrees clockwise. So 90 degrees clockwise. And in that case, you switch X and Y, but you take the opposite of your X value instead of your Y value. So let's look at what this happens. For this class, we're only going to worry about these rotations. Again, 90 degrees clockwise would be rotating this direction and stopping there. Okay? You can think of it as going through one quadrant. 180-degree rotation is completely turning it upside down, and it doesn't matter which direction you go. 270 degrees clockwise, again, same thing as 90 degrees counterclockwise. So 270 degrees counterclockwise is the same as 90 degrees clockwise. Same thing here. This was 90 degrees counterclockwise. That would be 270 degrees clockwise. So what does this mean as far as actually graphing? So find the coordinates of the vertices of each figure after the transformation. Now, it's going to say about the origin, because usually we're rotating here. When you get into higher level math, you may not be. But here's the key. We are traveling, or we are rotating 90 degrees clockwise. So which circumstance? That's 90 degrees counterclockwise, or 270. This is 270 or 90 clockwise. We're talking about this situation right here. So this is what I'm going to focus on. My x and y values are going to become y negative x. So what are my points here? I have, let's see, Q, R, S, T. Let me do them in order. Q, R, S, T. Now, I like writing the original ones first when I'm doing this, just because it helps me keep everything straight. So 1, 2, 3. Q is negative 3. 2. R is negative 2. 1, 2, 3, 4. S is 0, 3. And T is negative 3, negative 1. So when I rotate it, I'm going to get Q prime, R prime, S prime, and T prime. So what it's saying right here, this notation says Q prime is going to be what was the Y value in regular Q is now going to come first, and then the X value is going to come second, but I have to take the opposite of it. So that means change the sign. So instead of negative 3, it's going to be positive 3. So the point 2, 3 is where Q prime is. Doing the same thing with R. The Y value is now going to become the X value. And the X value, we have to take the opposite of it, meaning it becomes positive 2, and that's where our R prime is. 1, 2, 3, 4, 2. There is my R prime. S, 0, 3. 3 is going to become my X value. Opposite of 0 is just 0, so that one stays as that. And then finally T, Y value becomes my X value. And I take the opposite of X, which makes it positive 3. I forgot to graph S prime. S prime is right here. S prime. And then T prime is negative 1, 3. And I'm going to connect my dots here, and I should have something, again, same size, same shape. None of that has changed. It has just been turned or rotated 90 degrees clockwise. And I can see that it's gone from kind of this way to that way. Okay? So rotations are kind of funky. They're a little bit harder to see, I think, than the other ones. But we can still do them. So let's do a rotation 90 degrees counterclockwise. So 90 degrees counterclockwise, we're dealing with right here. So that means XY becomes negative YX. Okay? So, again, I like writing the original ones first. B, C, D. B is the point 1, 2, 3, 4, 5, negative 5. C is the point 3, negative 3. And D is the point 1, 2, 3, 4, negative 4. So let's see how this is going to change. To get B prime, oh dear, my pen is dying. C prime and D prime, let's see what I can do about that. Okay, B prime, C prime, D prime. So it's saying you take the opposite of Y. So if Y is negative 5, it's going to become a positive 5, and that gets listed first. And then X stays the same, it just becomes the second number in your ordered pair. So 5, 1. 1, 2, 3, 4, 5, 1. That is my B prime. C prime. take the opposite of y. Y is -3. It's going to become +3. And then your x value stays as is. It just becomes the second number. So 1, 2, 3, 1, 2, 3. There is my c prime. Yeah. And then my d prime, take the opposite of y. So that becomes +4. And then my x value as is. So 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. And I didn't label my points very well because I'm going to have to draw through them, but that's okay. There's that. And that. And back up. Okay. So again, find which one you're going to be using and then rewrite your points with those values. Okay. If you think you know what you're doing, go ahead and pause the video and complete the remaining 2 problems. Okay. These 2 problems, I'm going to draw the pre-image first. So -6, 2, -6, 4, -4, 4, -4, 5, -3, 3, -4, 1, and -4, 2. And when I connect those dots, I'm not going to use my ruler, I'm just going to freehand it this time, I end up actually with an arrow. So let's see how we are going to translate that. By the way, this one I think is the exact same arrow. Yep. So let me go ahead and get that one set up. -6, 2, and -6, 4, -4, 4, and 5, 3, 3. There we go. So both of these cases we're going to be rotating this little arrow guy. So this one we are rotating 90 degrees counterclockwise. So 90 degrees counterclockwise, let me get my point here, means that xy is going to become -yx. So change the y value and then leave the x value the same. Change the y value, leave the x value the same. Change the y value, leave the x value the same. Sorry, -4, -4. Change the y value, leave the x value the same. Change the y value, leave the x value the same. Change the y value, leave the x value the same. And change the y value, leave the x value the same. Okay? -6, -4, -6, -4, -4, -5, -4, -3, -3, -1, -4, and -2, -4. So you can see my rotation here is what we have rotated 90 degrees. Okay? All right, the last one rotated 180 degrees. That's where you take x, y, and it becomes opposite of x and opposite of y. So I'm simply changing both values. So that becomes +6, -2, +6, -4, +4, -4, +4, -5, +3, -3, +4, -1, and +4, -2. So you take a minute and go graph that. I'm going to graph it 2, 6, -2, 6, -4, 4, and we should have our arrow. Looks good to me. So that's how our rotations work. Okay, hope we are understanding this a little bit. Again, it's a little bit trickier. Just be careful as you're going for it. All right, happy studying.